One of the questions we always are asked are, have you seen a UFO, or are we alone in space? And so Enrico Fermi had a deep thought about this, and in something what we call Fermi's paradox, he thought about the fact that we are here and aliens are not. So let's first look about how this applies here on Earth.
So if life really is common in space, that indicates there must be some easy way for life to get started. And if that's the case, you can ask the question, why hasn't life got started many times on Earth? We look at the way the cells work of all species on Earth, from the most advanced to the least advanced. They all share large parts of their molecular material. For example, all the DNA is corkscrewed the same way. So it's clear that all life on Earth came from the same origin. But why is that the case? One would imagine, perhaps, that you could imagine that, in some stagnant pool in Australia, life got started. In a stagnant pool in North America, life got started in South America. And you might have got quite independent life forms with quite different biochemical bases forming in the different continents. So when Captain Cook first arrived in the east of Australia, he landed and saw what seemed some pretty weird life forms to him, like kangaroos. The kangaroos and the life forms in England were very closely related. They only split off about 60 million years ago. What would they found if there'd been a totally alien life form that was completely different? So that's a puzzle. If you really expect life to start that easily, why didn't it form more than once on Earth?
So it seems like it could be something to do with timescales. So when we look at things in physics, we're always having to worry about how fast things happen relative to each other. So imagine that life can travel around the planet at some rate, and life gets started at some rate. Now, imagine that travel time around the planet is much faster than the time scale of life forming.
Yes, so a reasonable timescale for life forming would be hundreds of millions of years. Whereas how long would it take a bacteria to get around the world? I mean, ocean currents and winds will carry bacteria around the world on scales of probably decades, maybe hundreds of years, but certainly not millions of years.
Yeah, certainly we know that things are able to, birds and stuff, for example, are able to fly around in periods of weeks. And so that means that if you are a new life form trying to get started, well, you're only going to be successful if you're fitter than the other life forms. And if you just started, it's pretty unlikely you're going to be fitter than something that's been going for a long period of time.
So whatever got going first would have spread all around the world probably before anything else had a chance to get going. So if you're species number 2 that appears, you have to compete with species number 1, which has had a 100 million year head start on you.
And that means you probably don't stand a chance. Sort of like a kindergartner going against someone with a PhD on math.
So the argument on Earth is that we don't expect independent families of life because the time needed to travel around the world is much shorter than the time needed to evolve. So whichever species appeared first, it would be everywhere before anything else had a chance to get going. Can we use a similar argument in space for intelligence? Once again, you've got 2 timescales. You've got the timescale needed to form an intelligent species, which on Earth is about 4 billion years. And then we've got the timescale needed to spread around the galaxy. If the spreading around the galaxy, colonizing the galaxy time is much shorter, then whichever species in our galaxy reached intelligence first would spread over the entire galaxy, back when all the other species were still at the level of slime molds, and there'd be no room for anything else to become intelligent. The aliens would be here already and in charge.
So let's think about this with respect to ourselves. We've only been able to go to space at all for, a few decades. But we could imagine right now, if we really, really wanted to, maybe going off to the nearest star. It would probably take the entire GDP of the world to do it, and it would take 100,000 years to reach there. So maybe it's a little out of reach right now. But, life's changing quickly.
Yep, so the question is, how long would it take us to colonize the galaxy? And as you say, building an interstellar spacecraft, we could do it now. It would be very expensive. But of course, the world economy is growing at 2% a year. At 2% a year, the world economy by the year 3000 AD will be about 300 million times bigger than it is now. Which means that, with a kid's pocket money, they could build an interstellar space travel machine. This sounds a bit ridiculous, really, economy 300 million, but just consider, let's say 1,000 years ago, people wanted to build an oil tanker. In principle, they could have done it, but it would have taken every blacksmith in the world the rest of their lives. Nowadays, an oil tanker runs off a shipyard every month somewhere in the world. So it's actually not at all ridiculous if we can keep an economy growing at a reasonable rate, that 1,000 years from now, interstellar travel will be trivial and cheap.
So that would mean that we would go off to Alpha Centauri or whatever, Tau Ceti, wherever the nearest place that has a reasonable planet. We would presumably colonize it. And when we got there, if there was any type of life form, we would either be ahead of it or behind it. Since it hasn't got to us first, presumably we're ahead of it. And we would then take over that planet and probably do the same thing to that planet that we've done to our own.
Yes, and you can ask, so let's say it takes 1,000 years to get to the planet. We have a multi-generation or suspended animation. But let's say the first settlers arrive somewhere. We can ask, how long would it take settlers who've just arrived on a new planet until that planet has a thriving industrial economy? And of course we know that number because it's happened many times, such as with the United States or with Australia. From the first fleet of convicts arriving in Botany Bay to the current booming economic superpower of Australia, it took about 200 years. So let's imagine some alien planet was going to be much more hostile than Australia was. So let's be conservative and say 1,000 years. So let's say the Earth sends out, say, 10 colony ships. After 1,000 years they reach 10 other planets, and each of them it takes 1,000 years to be industrial. Then each of them in turn can send out 10 more colony ships. So every 1,000 years you get 10 times more. So you get 10, then 100, then 1,000, then 10,000. Exponential growth. If you just take the exponential rate, we'll cover the entire galaxy well within 100,000 years. We can't actually do it that fast because the spaceships are limited to the speed of light. So eventually we have a wave of ships spreading at the speed of light through our galaxy, or whatever fraction of it our technology can achieve. But certainly within a few million years, maybe 100 million years, we could spread over the entire galaxy, even without any major breakthroughs like warp drive.
And so that 100 million years, of course, is even that 100 million years, which seems kind of conservative, is still pretty fast compared to how fast life evolved here on Earth. It took us 4 billion years to get going.
So that was Fermi's argument, that the timescale, even if you're very pessimistic to spread around the galaxy, is much shorter than the timescale to evolve intelligence. So the fact that aliens aren't here and weren't here long ago when we were at the level of slime molds is telling us, according to Fermi's argument, that we probably are alone, at least in our own galaxy.
And presumably that you could argue that, well, maybe the aliens are just nice. But presumably there's some not-so-nice aliens out there who would have done it. So really, it seems like we may well be alone.
Yes, I mean, there are lots of possible ways out of this argument. As you said, one idea is that maybe aliens are maybe the prime directive, and they come here and say, oh, look at those primitive little slime mods, we'll leave them alone to flourish in their own way. But then all it takes is one nasty species,
The Klingons, for example.
Klingons, to take over and dominate. But it could well be that, for example, if we've had the argument we've already talked about, that intelligent species don't stay intelligent very long, maybe we destroy ourselves before we get the chance. But again, all it takes is one species that doesn't destroy itself to dominate the galaxy. Maybe, you could imagine other arguments, maybe interstellar travel is much harder than we really think. Maybe species inevitably become so philosophical, or maybe there's some great religious truth that all species discover and they spend the rest of eternity contemplating their navels or doing whatever this religious truth indicates. But unless there's something that stops species expanding like this argument suggests that whoever gets there first will dominate, and we are alone.
Maybe it'll be us.